Okay, so now I'm going to do a single replacement metal plus acid. Work problems, there's three of them. For these, you'll be using an acid instead of ionic compound. Uh, and I went over why you can do that in the PowerPoint. And one other thing is that the only acids we'll be using will be binaries, okay, not the tertiaries. Okay, but if you take Chem 121, we will use tertiaries. All right, so here's the three that I put in on the worksheet. Again, we're going to finish the word equation and balance equation and show it's being oxidized and reduced. One of the key things we got to do is we got to change the acid name as formula to its ionic form. And that's so we can balance it and write the equation better. Hydrogen, when it's all by itself here, will be H2 with no charge. It's not H2O, that's water. It's H2 with no charge on it. Okay. The other things I notice sometimes people do is instead of using an arrow between showing the product, they'll use an equal sign. Don't use the equal sign because the two sides are not equal. All right. In fact, that's the definition of chemistry. So you're going to change. The other thing is always put your pluses in. I've had students just leave the pluses off. All right. So beware of the superscripts represent charge. So if you had S, 2 minus, the number up here is the charge on the atom or molecule, and number down here is how many atoms. All right, so let's go with the first one, hydrochloric acid plus magnesium. Okay, before we do anything, let's change the acid to its ionic name, so it's hydrogen chloride plus magnesium, and then finish the equation to swap the hydrogen. The magnesium takes the place of the hydrogen, and the hydrogen comes out, so you have magnesium chloride plus hydrogen. Write the initial equation, HCl, H plus Cl minus, Mg0, no charge because it's all by itself. Mg2 plus because it's an ionic compound, Cl minus, and you need to crisscross charges because they're different. So you need to have two Cl's because there's two plus charge here. And then H2, again, it's not like the metals. The metals will have no subscript, okay, but hydrogen will. So it's H2 with no charge. Okay, so that's the initial equation. Okay, next thing we got to do is balance equation. Again, start with the negative ion. Okay, and you need to have two chlorines, so you're going to come over here and put a 2. Okay, and then check your hydrogens. You got two hydrogens here. Notice you have two hydrogens here. You have one magnesium here and one magnesium here. Don't worry about the charges. You don't balance the charges between sides because they'll end up being balanced anyways. Right, so that's it. You're done. What's being oxidized and reduced? Hydrogen is going from a plus charge to no charge. Okay, even though there's two of them, it's still hydrogen. So it gets more negative because it because it gained electrons, or less positive because it gained electrons. And magnesium did the opposite, became more positive because it lost electrons and it was oxidized. So reduced, oxidized, reduced, oxidized. And chlorine has no change. All right, next one, aluminum plus hydrobromic acid. Change the acid to ionic, so it's aluminum plus hydrogen bromide. And then aluminum's going to take the place of the hydrogen, and the hydrogen comes out, and you get aluminum bromide. Write down your substances. So it's aluminum, no charge because it's all by itself. Hydrogen bromide, H2, no charge. Al3 plus, Br minus. And so you need to have three of these. Now this one's difficult to balance, and so you won't get one like this on the test. But it's not straightforward. You just can't start with the Br because it gets messy. So if you said I have 3 BRs over here, come over and put a 3 over here. And then notice that your hydrogens and are not balanced, so you have to make them common, so you make both sides 6 and so forth. And then you get this, but you'll see that now it is balanced. Okay. And if you could do it, that's fine. That's great. That's what you're supposed to be able to do. But and I left something out here. I got to put 2 here. All right. Okay, now it's balanced. Again, aluminum head goes to no charge, 3 plus charge, so it gets more positive and lost electrons. The hydrogen gets less positive, so it gets more electrons, so it gets reduced, and nothing happens to the bromide, so it's a spectator. And the last one, hydrofluoric acid plus silver. Again, change the acid to its ionic name, hydrogen fluoride plus silver. Yields hydrogen and silver fluoride. So H plus F minus, Ag0, don't forget, no charge. H2, no charge. Ag plus F minus. Okay, now you're all set. And balance equation. Alright, so I need, so I have, where do I start? So I have, okay, so I have 2 hydrogens, so what I'm going to do is come over here and put a 2 here. So I didn't start with negative ion. So I need to have 2 hydrogens. Okay, and then the next thing I do, now I had to have 2 Fs. So I come over here and put a 2. Then finally, I have 2 Ags, so I have to come over here and put a 2. All right. And you can see what gets oxidized and reduced. So the silver loses charge, loses electrons, hydrogen gains electrons, and the fluorine is a spectator. So electrons are moving from the Ag to the hydrogen. And that's really a special thing about acids. Is acids, because of this hydrogen here, is a really good oxidizer, and it can gain electrons really easy. It's almost as strong as the oxygen when it's combined with metals. Okay, that's it. And I'll do the next couple.